video, we're going to start talking about how to graph rational functions, and there's some things that we need to know about just the equations in general. So there's some things that are going to happen because we have a denominator, and a lot of times that's going to produce values that x could not be, right? It's going to be undefined if my denominator is 0. So that's going to create some asymptotes within our graph. So we're going to look at how do we find where those are. So the first thing is to remember, how do we find those excluded values? So remember, we just set the denominator equal to 0. If it's factored like this, remember that just results in two different equations. So here, x could not be -1 or 3. Those would be my excluded values. So the domain, we could write like this, or remember, this is going to be -infinity up to -1. Don't include -1, so it's going to be a parenthesis. And then we use this union symbol to say it could be in here or in here, and that's fine. So then anywhere between -1 and 3 is okay, but -1 and 3 are not okay. So same thing, we use the parentheses, and then anything above 3. So 3 to positive infinity. So this would be the way to write that domain with interval notation. This is kind of the shorthand of saying what x could not equal. Okay. So here are some rules. We're going to get some different asymptotes anytime I have two rational functions. So if I have a fraction in my expression. Okay, so we're going to call the numerator p of x and the denominator q of x. That's just to help us kind of keep track of some of these rules. So we're going to look at the degree of these. Remember, the degree is what's the highest exponent. So if the degree of the numerator is less than q, the denominator, then I always have a horizontal asymptote of the x-axis. Okay? If the degree on top is greater, then I don't have a horizontal asymptote. And if the degrees are equal, we're going to get a ratio of the leading coefficients. So this would be an example of that. So here, my degrees are both 2. So when they're equal, I just look at the leading coefficients. So 2 and 3. So I would have a horizontal asymptote at y equals 2/3. So that happens when the degrees are the same on the top and bottom. Okay, we also often get vertical asymptotes with rational functions. This is where my denominator equals 0. So I only look at q of x and I ask myself what would make the denominator equal 0. So here, again, you can set them equal to 0 if that's helpful. So x minus 3, x plus 3, if you set that equal to 0, right? Same thing, you can set up two separate equations. So I'm going to get x equals 3 is a vertical asymptote, and x equals -3 are vertical asymptotes. So that means those are kind of like border or boundaries where my graph will never cross. It will approach those values, but it will never cross vertical lines going through 3 and -3. Okay, we can also have something called a hole, and this happens anytime I have common factors in the numerator and denominator. So for example, here you can see we have an x plus 1 and x plus 1 in the numerator and denominator. So what value makes that equal to 0, since it's in the denominator, would be -1. So I have a hole at x equals -1. Okay, we still have a vertical asymptote for this one. So the common factors are holes. Anything that's not a common factor in the denominator is a vertical asymptote, and it's what value would make that equal 0, okay? So the hole kind of trumps the vertical asymptote. It's a hole instead of a vertical asymptote if I have that common factor. Okay, to find zeros, this is where I set the numerator equal to 0 and solve. So these are kind of the 4 things you guys are going to be asked to do, or maybe there's 5 here. So we're going to be asked to find the domain, horizontal asymptotes, vertical asymptotes, holes, and zeros. Okay, so we're going to do that on this next page here. All right, so what's most helpful is to factor if it's possible. So here I could factor my denominator using difference of squares. Okay, so things I want to talk about. I want to give the domain. So this is what could x not equal. So x could not be -1 or 1. That would make our denominator 0. You can write it just like this, or you can write interval notation. If it asks for interval notation, be sure to do that. Okay, the other thing we're going to talk about is horizontal asymptotes. So horizontal asymptote, okay, this is where I want to look at the degrees. So the degree of the numerator is 1. The degree on the denominator is 2. So if the degree on the bottom is bigger, then we always have a horizontal asymptote at 0, okay? All right, vertical asymptote. It is those values that made our denominator 0. There were no common factors. I couldn't cancel anything. So those are my vertical asymptotes. X equals -1 and at x equals 1. Okay, what else are we going to find? Holes, there are none because there's no common factors. And the other thing we're going to find is zeros. So that's where I set my numerator equal to 0 and I solve. So x equals 0 is a 0. That means it's going to cross the x-axis at 0. So I'm actually going to put this as a point, okay? So x equals 0, when y is 0, x equals 0. Okay, let's do this one. So this is for the top one. Okay, we're gonna do those same questions. I can't factor anything here. So domain, x could just not be -2. Okay, horizontal asymptote. So my degrees are the same here. They're both first degree. So my leading coefficients are really 1 and 1. So y equals 1 over 1, which is just 1. Vertical asymptote is that value that makes the denominator 0. So it's x equals -2. There are no holes because there's no common factors. Zeros. Set the numerator equal to 0 and solve. So I've got x minus 2 equals 0. So x equals 2. So the point 2, 0 is where it's going to cross the x-axis. Okay, this is the sum of cubes, so this will factor. Here my a is x and b is 1. So we've got x plus 1, x squared minus x plus 1. And then x squared I can leave on the bottom. Okay, so let's go through our same questions. Domain, what could x not be? X could not equal 0. Horizontal asymptote. Okay, so my degree, this is something good to know to you guys. It's easier to see the degree in this form, but if it's factored, you just add your exponents of your factors. So 2 plus 1 is 3. 3 is greater than 2. If it's bigger on top, there is no horizontal asymptote. Vertical asymptote. What made our denominator equal 0? 0. No holes. Okay, zeros. Okay, so here, when I set my denominator, I'm going to set the numerator equal to 0. So I've got x plus 1 equals 0, and x squared minus x plus 1 equals 0. Okay, so here I'm going to get -1. So I've got -1, 0. This one is not going to factor because that's already completely factored. So you're going to want to use the quadratic in this case. So I'm going to get -b, so -1 is +1, square root of b squared minus 4 times a times c all over, let's see, 2a. Okay? All right, doing some simplifying here, I'm going to get 1 minus 4 in the denominator. So these are going to be complex roots. So here I would get, I'll just write out +1. And then I'm going to get 1 minus 4, which is -3. Okay, so if we're asked to find zeros, I could write this as 1 plus or minus I root 3 over 2. but there's not going to be any place where I see that cross the x-axis. So this is the only 0 where it crosses the x-axis, so that's the only one that's going to be helpful for the graph. But I do have 3 zeros technically because it is a third degree polynomial. Just 2 of them are complex. So this is technically goes in there, but okay. Factor my numerator here, so I've got x plus 3, x minus 3 with difference of squares. Okay, so here we are going to get a whole on this one because I do have common factors. So let's write our usual. So I've got domain, x could not equal 3. Horizontal asymptote. So again, I'm bigger on top, so there are no horizontal asymptote. Vertical asymptote, there's also none because my denominator is actually going to result in a whole. So the whole at what makes that be 0 is 3. Okay, so that's why I have a whole there. Zeros. So after I cancel out my whole, then what's left, I set that equal to 0 on the numerator. Okay, so x equals -3 would be the 0 or the place where it crosses the x-axis. Couple more, okay. Here it's helpful when you guys factor out a numerator, factor out a -1. So I'm gonna get -1, 2x, and then I'm going to go ahead and factor numbers that multiply to be -2 that add up to be 1 are 2 and -1. And then this one here, I'm going to get numbers that multiply to be -3 that add up to be 2 are 3 and -1. Sorry, that should be a 2. There we go. Okay, so now let's answer some questions here. So domain, what could x not be? So anything in the denominator that would make our denominator 0. So here I have x could not equal -2 or 1. Vertical asymptote, or excuse me, horizontal asymptote. My degrees are the same, 2. So my leading coefficient is -1 and 1. So y equals -1 when I divide those leading coefficients. Vertical asymptote. So this one I have a whole, right? So we have a whole with the -1, x minus 1s. So what would make that 0 is x equals 1. So that one is not a vertical asymptote. The vertical asymptote would be the other value that makes the denominator 0, which would be x is -2. Okay, now our zeros, if I set the numerator equal to 0 after I've canceled, so I've got -1 times x plus 3 equals 0, x plus 3 equals 0, so x equals -3 would be an x-intercept. Okay, last one here, you guys. This will not factor. Okay, so the degree is bigger on the bottom. There is nothing that I could put in here that would make the denominator equal 0, so my domain is all reals. Okay, if I set that equal to 0, I'm going to get a complex number. Okay, horizontal asymptote, it's bigger on the bottom. Vertical asymptote, there is none. Again, maybe I should show that, right? So x is plus or minus I, okay, which that's not a real number that I can see on a graph, so we don't have a vertical asymptote, and my domain is all reals. Okay, we don't have any holes, and zeros, we don't have any of those either. If I set 1 equal to 0, that's not possible, so I don't have any x-intercepts. So this one's kind of interesting. It's not a lot of restrictions on this one. Okay, so horizontal asymptotes, those are things that tells us about the ends of the graph on the very far left and very far right. It is possible for our graph to cross a horizontal asymptote in the middle. Vertical asymptotes are absolute. You can never divide by 0, so you can never cross a vertical asymptote. Okay, and I think that is it for this video, guys. Thanks for watching.